little bit nervous about this concept, and I'm ready to be embarrassed. But the idea that we're going to try and talk about is a little bit about my history, and then about 10 minutes, and then about 45 minutes on the concept. I'm going to throw a bunch of ideas out at you very fast. Sorry, I'm going to have to read a lot of the slides. I've never done this presentation before. I threw it together pretty quickly, and so excuse the presentation. Just try and get your head around the ideas. And I'm going to blast a bunch of stuff at you, and then we can talk about it afterwards. There'll be a lot of information that's a little bit sketchy on the details, but just kind of let it roll over you, and we'll have hopefully an interesting experience. And the idea is we're going to conceptually discuss wireless electric vehicle charging, CO2 drawdown using mineralization. So let's just go a little bit about who I am. I work for SMUD. My day job is I work on business strategy for energy storage behind the meter. I'm also subject matter expert for energy storage and wireless power transfer. I have a history. I was born in South Africa. I left South Africa when I was 15, came to the UK, lived there until I was 30, came to the US in 94. Entrepreneur, I had a software company up until the year 2000. Then I did attempted the world speed sailing record down in Corpus Christi, and then I started a biofuel company with a single Willie Nelson, and then sold that. Moved to California about 2007, started a company called Renewable Fuel Products. There's a food and fuel system to sequester carbon into farmers' fields and produce renewable diesel. I'm also the founder of the Davis Funding Club and the Urban Air Mobility Coalition here in Davis. I'm best known for Willie Nelson, though, and interesting enough, there's a picture here while I was putting it together. It's appropriate for the election time. We fueled John Kerry's bus, and it's in 2004, and we like John Kerry because he's a windsurfer, and there are about 20 of us who are windsurfers, and that was his voting block. We're single issue voters. It wasn't a strategy he won with, so maybe somebody else to think about, but we like that. So I'm a windsurfer, and I don't have any expertise on climate or water or anything like that, but I exist on the interface between water and the air on a regular basis, and I feel it through my entire body. So that's my experience. I have probably 10,000 hours worth of experience in that, but no scientific background. So some of the stuff I work on at SMUD, on strategies, I came up with a strategy called the community battery, and it's trying to deploy batteries into multifamily homes that are typically left behind in the energy transition. So this is a place that we're pioneering this project. Chesapeake Commons, low to medium income complex, about 600 apartments. We're starting off with 80 batteries with solar behind each meter, 100% controlled by the utility. So we dispatch the batteries. It's quite a unique project, never been done in the country. Pioneered in Utah for a new build, but this is a retrofit. So it's an interesting concept. We've got about 80 batteries going in. It's going to go to about 600 with one particular company. We're then going to blow it out, hopefully, if it goes well, to all 4 Wasatch properties in our territory. That represents about 1,400 apartments, about 10 megawatts worth of dispatchable power, and about 30 megawatt hours worth of energy reservoir. If that goes well, we're going to blow it out to the rest of the territory. We have about 1,500 complexes in our territory, about 100 apartments per apartment. So it's about 150,000 apartments. So that represents about 3 gigawatt hours worth of potential energy reservoir that we can dispatch in what we call the grid of the future. This is a two-way grid. So we sell power to the customers, the power sells back to us, we pay for grid services. So it's a very different model than the old utility model, which is single transmission. Other projects that I've worked on is the distribution system. How can we avoid upgrades for substations? So this is using a battery to defer a substation upgrade. We have about 21 substations in our territory that need to be upgraded. It's about $90 million to upgrade them all. If we put a battery in its place, we can defer that. It's about $40 million to put the battery in. So it's a pretty interesting financial method to avoid this kind of stuff. And one of my pet projects that I'm allowed to go work on, which is fantastic, SMUD allow me to go do that, is to investigate this concept of power on the road. So this is my passion project. Full disclosure, this is not a strategy SMUD is doing. This is not a policy they're doing. This is just purely my pet project. And these ideas are for discussion and for ideation only. So this is nothing to do with the organization at all. Okay, so let's talk about the three concepts that we're going to discuss here. So the transition from to electric power offers us this ability to lower the cost of transportation. And at the same time, we can take that revenue and use it to finance CO2 drawdown. So that's the holistic view of it. So there are three concepts that we can talk about here. This is this idea of air to liquid mineralization. We can theoretically draw billions of tons of CO2 out of the atmosphere per year. At a price of $100 per ton, the world will need somewhere around $500 billion a year of demand to get us in our climate goals, and a mechanism to finance that doesn't exist. It's a huge amount of money. So the second concept is wireless charging. So luckily enough, what lies at the heart of the energy transition is this shift from expensive liquid fuels down to relatively low cost electric transportation. And that comes from this efficiency gain. And there's a further cost potential advantage that if we do this right, recharging continuously via electric roads can bring the cost of charging down even further than the stop and go recharge model. And then the final concept to get your head around is really the idea of a non-profit utility. Because a utility is really the best place to deploy wireless charging to a community. So this asset can be available to all the citizens. And revenue generated from this asset can be delivered by a non-profit utility and spent on sequestering CO2 out of the air, whereas a for-profit utility wouldn't be able to do that because that money has to go to the shareholders. So these three concepts together is essentially the innovation. So it's nothing unique, and we're not inventing wireless power, we're not inventing drawdown. What we are inventing here is this combination of all three together. So the innovation is really stopping, don't go stop for your fueling, drive your car around, get charged up, and use that innovation to generate money to draw the CO2 out of the atmosphere. And the reason we think it's going to be quite exciting is power on the road offers a far better refueling experience than stopping for gas or stopping to DC fast charge or at home. So I call it refueling 1.0. You could charge your horse because it could fuel itself as it went around because it had this bag on its face. Yeah. Then we went backwards. So we essentially went to a stop and go recharge at gas stations. And that's like the Blockbuster idea where you go to the store, you pick up your CD, and it's like, no, there's no Blockbuster left. I think there's one left in business. Yeah. So the next step really is the Netflix of power transfer. Can we move to this? I call it refueling 3.0. So let's talk a little bit about emissions. If you look at the emissions, if we do nothing, we're probably going to blow past our 2 degrees of warming. SMUD is an organization. We have a goal to get net zero by 2030. But even if we do all that, by the year 2040, we're probably going to diverge from this idea of being able to meet this 2 degrees threshold. So somehow we're going to draw CO2 out of the atmosphere. And to me, it's really depressing. I mean, it's so depressing that we're going to blow through our budget maybe within 5 years. And to get up every day, we work on electrification. We work really hard on all this stuff. And we're not really much we can do about it. It's just a question of how bad it's going to be. So to me, I find that very depressing. And so I try to work on something a little positive. I'm a glass half full person. And so I'd like to be optimistic. So one of the ideas that's around is direct air capture. We can essentially vacuum the CO2 out of the atmosphere. But unfortunately, the rate of withdrawal right now is not very successful, maybe 10,000 tons. Last year, we're not being very successful. It's hugely expensive, very, very energy intensive. So are there other ways to go do this? So as a windsurfer, I'm aware that the ocean is the largest contact of the atmosphere. And are there different ways to get CO2 out of the atmosphere? So there's a bunch of ways to do this: direct air capture. You can fertilize the ocean, you can go get a bunch of algae, let it drop to the bottom. But one of the areas that I'm most interested in changing the pH of the atmosphere and mineralization of the ocean to reduce its acidity. So there's a bunch of companies that are quite interested. One of them is Planetary Tech. It's an interesting company. They call it ocean salinity enhancement OEE, and essentially adding an anti-acid to the ocean to reduce its acidity. This is a very common substance that you typically have for milk of magnesia. It requires high purity magnesium oxide, and it's well used throughout sewage works throughout the world, and also in your home remedies. So that's one technology. Where you go and get this stuff from is quite interesting. So this is a mine in Quebec. It's called the Tetra mine. There are companies like CO2 that actually go through the mine tailings and take out the magnesium oxide and make it a high purity version. And you'll notice in the left-hand corner, it's called the Bell Mine. And if you remember from the start of the presentation, my name is Bell. And so we have an interesting history to this. This place is actually called the Bell Pit. So my great-grandfather went to Canada and he bought this asbestos mine. And we sold it in 1906. So we sold it as a family. Nobody knew then asbestos was dangerous at all. It was regarded as a miracle material and fireproof and all this kind of stuff. And a wild coincidence is my sister's son is now head of DuPont Sewage Works. And so 5 generations, we may be able to heal the earth by this giant hole that my great-grandfather put in, that my sister's son could go and put this stuff back in the ocean and help heal the climate. So it's a weird coincidence, but that's my family history involved in this. And so we've connected up with a very interesting company here out of Oakland called The Quarry. And they're going a little step further around abandoned mines. So the idea is that abandoned mines represent a massive contained body of water that are polluted to right now. And so if you put this magnesium hydroxide in, it doesn't have to be as pure because you can't mess up the environment anymore. And so you can contemplate a situation where $50 a ton is possible. And there are about 10,000 of these mines abandoned throughout the world. And you need about 3,000 to get about to 30 billion tons. So dealing with all these individual legislators is very, very difficult. It's complicated, but the opportunity is there for you. And what's pretty interesting is there are 3,000 utilities in the United States, and they deal with individual legislations. So you could see a concept where each utility adopts an abandoned mine and uses revenue from the road to buy these CO2 to put it into this mine. And to get an idea how toxic some of these mines are, there's a place just up the road from us. It's called Iron Mountain. It's the most acidic water on the planet, as far as I understand. You can see negative pH coming out of the place. They spent $1 billion trying to remediate that so the water doesn't go into the Sacramento River. So there are plenty of these places out. And if each one of these utilities took on this project, you could see a situation where we get down to 310 parts per million, i.e. the atmosphere level that was there when SMUD started in 46. So we can lead the way if we choose to and use this concept to finance this drawdown. The challenge obviously is, how do you finance this? We realize that we need to bring this stuff down. Then there's no mechanism like carbon tax. So how do you finance this thing? The demand requirements, somewhere around $500 billion a year. That's a massive ask, yeah? So in this transition, we realize there's a shift from expensive fuel to cheap fuel. We know all this kind of stuff. And we're moving from fiery molecules to obedient electrons. And you get this transition through this the mileage advantage. You look at a Tesla utility truck, you're probably going to get 100 or so kilowatt hours to go 100 kilometers. A diesel truck will probably be 3 times that for the energy put in. So that advantage is what you're going to try and play on. And the business model here is really working on that. So if you put fuel into a car, you're probably going to get 10, 20% out of the wheels, whereas an electric car, you're going to get 80% of the energy is going to be useful. So that advantage of essentially spending $3 to go 20 miles versus $1 to go 20 miles in an electric vehicle, you can take advantage of that. And it's a very big addressable market. Just in the United States, we use about 130 billion gallons worth of gas every year and about 45 billion gallons of diesel. So it represents massive markets if you can take this on. And so the utilities have the opportunity to lead. So we have about 3,000 utilities, about 1,900 of them are publicly owned. So like SMUD, they're owned by the residents rather than investor owned. And there are about 4 million miles in the United States. About 2.5 million are paved. About 170,000 of them are highway miles and about 47,000 are interstate miles. And the interesting thing is about a quarter of the road traffic is actually on highway miles. So if you went and sold power at 5 cents a kilowatt hour, this is what we buy PPAs at, and you sell it at 20 cents a kilowatt hour, there's about a 15-cent margin. So that's a very, very interesting revenue opportunity. It's about $30 billion a year in profit that utilities could use to help finance some of this stuff. And the cost is about $1 million a mile, roughly, if you did it at scale. So it's about a $170 billion investment to go and do this in about a quarter of the roadways. So you get a long way down this track if you took it on at this scale. So bring it down to Sacramento. Millions of miles are driven in Sacramento. About $5 billion a year is spent on liquid fuels. And so it represents about $1.5 billion of revenue, new revenue for SMUD, or utility like SMUD, which is publicly owned, to capture that revenue. And we could spend some of that on giving the money back to our residents and also capture CO2. So we could think about drawing down our utilities. Instead of going to net zero, we could think about going to absolute zero. So since 46, when we started, to the year 2030, when we're going to be at net zero, it's about 84 years. We emit about 2 million tons a year, roughly. And so it's about 160 million tons a year. At $50 a ton, it's about $8.5 billion to spend. You could do that in 5 years. So it's not unattainable. So we as a utility, we face dramatic challenges for EV adoption. Upgrade for infrastructure is a big barrier, costs are a big barrier, and battery costs are also a big barrier to fleet adoption. For example, in our territory, we have to put in about 1.5 gigawatt hours of storage. We have a bunch of bulk stations. We have 230 substations. To upgrade that to handle EV growth, which we see is about 30% from EVs, about 10% from electrification, our exposure is somewhere between $5 and $8 billion. So that's a large amount percent to be added to our revenue costs. That's our exposure. Hopefully we're going to try and avoid that. And there's a possibility of doing that. So if you do smart charging with our EVs, you charge them during the day, and we avoid these peaks. So like a TNC driver, or the graph here, it mimics our EV charging of regular drivers. So we see this peak around about 8 or 9 o'clock in the morning, see the peak going at 5 to 9 in the evening. We want to shift that into the middle of the day using solar or other renewables, so you don't peak the grid. And you can see our grid can actually handle way more load than we actually think it is. So if you look at the chart here in September of 22, we typically run about 1 gigawatts, but it peaks at about 3. So our grid can handle 3x what it's doing today, as long as you go around individually and stop each spot from peaking. And so if we carefully manage this with energy storage, and the batteries in vehicles represent the large storage, then we can potentially stop this peaking from going on. So then we come to wireless charging. So the idea is, imagine a fleet runs all day long, in the evening it goes and charges. It's exactly the wrong time when you want this thing to charge. Whereas if you go to wireless charging, then you can charge the vehicle all during the day as you drive around. So we're not going to peak the grid. So we can transform idle and driving time into charging time. We can put these wherever you go, docks, facility entry points to any of these facilities, and we can do dynamic charging while you're driving. So we can extend the range of any vehicle. We can run to 24/7 if you want. You don't have to make your batteries any bigger. It's a very cost-effective solution. It can scale to any architecture. You can have a small road vehicle versus a giant 18-wheeler. It's accessible wherever you go. It happens automatically in the background, and there's no change to the real estate required. You don't have to put the stuff in the way of your yard if you're a commercial unit. And it allows this idea of distributed charging or opportunistic charging to occur, so we can balance our grid. And one of the companies, White Tricity, trademarked this thing. They call it power snacking. So you take these little snacks of energy as you go around, rather than peaking the grid. So we don't have to upgrade our distribution system to handle EVs. We can snack the power as you go around. So obviously now you guys you're totally familiar with this. Obviously, these are the different types of charging. We're going to talk a little bit about wireless charging. and how that relates to dynamic charging. And if you're not aware, most of the charging occurs through induction. You create two coils, they create a magnetic couple, and the power goes between the two. So the stuff you use in your toothbrush is pretty safe. You put it in water, you're not getting shocked. There's a new strain that's going around called capacitive transfer, and that's a new area that's quite interesting. It's lightweight, it's low cost, but it's very, very new. Induction charging is a long way down the track. And we see a lot of stuff coming up out of Oak Ridge where the power transfers are now exceedingly effective. So this is a Kia 5-inch gap, around about 100 kilowatt power transfer, around about 95%, 96% transfer efficiency. There's this magic Porsche Taycan. They put a 300 kilowatt pad on it and it fits directly into the existing wireless pad facility, so it's not a hard retrofit. And these pads are about 0.5 meter in diameter, and they can do at a 1 meter scale, 1.5 megawatts worth of power transfer. So it's amazing how powerful they can transfer the power and the efficiency. If you go look at some of the companies commercializing it, Hevo is a company that's doing this. They get about 90% transfer efficiency. And what's neat about Hevo is it comes with a plug as well as a pad, so you're not shutting out the plug people when you show up at your charger. And the reason you can get this efficiency comes back down to this basic electronics idea. So if you look at the top shelf there's an air gap between your inverter and your rectifier and a wireless system. And in the DC fast charger, AC fast charger, there's an air gap somewhere in the system. You have to have this air gap. So this is why you can get close or almost parity to a plug. And so then you talk about, well, how about the two features of wireless, why it's so interesting? So interoperability and desirability are the two features. If you show up at a pad, it doesn't matter if you're in a different type of vehicle, they're all interoperable because of the standards that's being set up. So you can be in a small vehicle or a giant truck, it doesn't matter, the same infrastructure to use it. And the second bit is the desirability of these features. If you look at this survey done by Electricity again, there were 3 features that topped the list: range, rapid charging, and wireless. And if you're a statistician, they're very close. The difference is in order of error. So these are the top features that people are looking for, whether they're a current owner or a soon-to-be owner. These are the desired features. Yeah, it's just easy. So, and you can understand why these are some of the benefits. You rock up at the wireless facility, you just drive up and park. You don't have to think about this forest of plugs, what you're going to put in. Is it going to work? I mean, the reliability of these plugs is dramatically down. I've got some great examples here. A plug was pulled out by a vandal. The next one down is a cow walked between the car and the charger and pulled the plug out. This is one in Roseville where the plugs, all the pins are all bent. You just wouldn't want to put it in your car. This one's got a spider in it. It's like you just want to pick it up. The other one's got a bunch of, so all the pins are all melted. This one was hit by, the Tesla charger was hit by a car. Somebody thought it was a great idea to put a cream egg in it. It's like, yeah, thanks. This one caught fire. So there's a bunch of benefits. We can go down the list. They're much faster. It's more convenient. There's no theft. All these kind of features are benefits of wireless charging. And then you get to the situation where it's much safer than plugging it, especially at very high power rates. So if you look at this charger here, this is almost a 4 megawatt charger. When our techs go into the substations, they put on a bunch of PPE. There's a whole bunch of safety steps that they take before they plug it in. This thing, it's going to be plugged in twice a day for the next 10 years at 7,000 changes. What are the odds across 6 million trucks in the United States that there's going to be a catastrophic failure of a plug? At 4 megawatts, the outcome's pretty bad. So this is my own personal experience. This is at SMUD headquarters. We're a first-class facility. It's all top-of-the-line stuff. But I'm expected to plug my little leaf in standing in a puddle of water. And we're told in engineering class, don't do that. And this is a photograph of the spider that was hanging out by a plug. I'm not sure if it's a venomous spider or not. If I had a wireless charger, I wouldn't encounter that. There's obviously huge stories about the bolt. Had to have 10,000 cables recalled. There's a product that's been invented called EV Eject. So if you're parked in a place, you can actually drive off and your charging cable will let go. So if there's somebody creating a product, this must be a fear. And then you talk about all the vandalism. This was a story taken out of Minneapolis where vandals stole about 46 of the cables, cost them $46,000 to replace them. So you show up at the charger and you go, wow, I'm ready. And it's not connectable. So these are the challenge. And so when you come to a situation of disabled folks, we may be discluding an entire genre of folks from using an EV because it's so hard to get to the charger itself. You look at the Circle K one, you can't get up on the step. And in SMUD, we're all about diversity, including everybody. This is the cables on our side. You can't get your wheelchair down between to get to the charger. So we may be scaring a whole group of people off by going with a plug. And then you think about the diversity of plugs that are out there. Just across the AC and the DC version, it's the Betamax wars all over again. And then you've got to carry the different plugs in the back of your trunk. You don't go to the gas station and carry 4 different adapters in the back of your car. You just go to the gas station and stick it in the tank, yeah? And then you think about fleets. Are we going to be in a situation where there's a 1-to-1 ratio of charging to the vehicles? This is very, very complicated. And then you get into the cost of these things. This is a plaza that's set up down in Southern California. About 27 million grant was required to put it in place. That's about $1 million per charging spot. So $350,000 to charge one truck. The truck costs about $250,000 compared to a diesel truck at $150,000. So this is about 4 to 5 times more expensive than a diesel truck. And we're supposed to be getting the benefits of being lower cost, not the other way around, yeah? And it only gets charged to 80% in 90 minutes, whereas you can do your truck in 10 minutes. This is a plaza coming up in Livermore, and their mission is to be at parity with diesel or competitive. And this is for 92 different places, $20 million project. Again, stop and go. And then you see this all over TikTok. I mean, we're not quoting TikTok, a scientific thing, but this guy here, he charged his Mercedes to 10%. He cost him $15, and so the message is getting out there. Charging by electric is more expensive than regular fuel. Not the opposite of what we'd like to see, which is you get an economic benefit from going electric. And then our competitors, so this is Neste, a giant oil company. They come along to the fleet provider and say, hey, change your fuel, not your fleet. It takes 10 minutes to fuel up your truck, not 90 minutes to get to 80%. So electrification is not guaranteed. We think it is, but it's not. So when you come along and you to a gas station, it's put your credit card in, 5 minutes later you drive away. Compared to an electric car, it's you download the app, put your credit card in, sign up, all this sort of stuff, and then 30 minutes to refuel to get to 80%. You're not better, you're not faster, and you're not low cost, you're not going to get rapid adoption. So I think plug-in charging is a crowded marketplace. It's a bunch of walled gardens. There's interoperability issues, and replacing the combustion fueling charging mechanism with the same thing is challenged by all this power availability from utilities like us. It takes so long for us to produce that. We're going to peak our grid, and it still only offers a slower and more complicated refueling experience. Yeah. So I think Power on the Road has an opportunity to offer a better experience than liquid fueling or plug-based fueling, and so we get better, faster, and lower costs. So we might see rapid adoption. And EVs, that's what I'd like to see go. And then the final concept is that Utility SMUD is a not-for-profit organization. We're governed by an elected board of directors, and so we can take revenue from this kind of asset, and we can use it for buying CO2 drawdown. So I asked the question, would a publicly owned utility like SMUD be the best place to capture this revenue from EV adoption and use wireless charging and make that a community asset that's available to all citizens? So that's the question I'm asking. So let's talk about the various use cases. So Lectron shows the different cases here: dynamic charging, semi-dynamic, and stationary charging. A neat feature I see that you can get rid of the transport in your garage, because the little app tells you where to park exactly, so you're not going to hit the end, and you know your garage door's going to close behind you. So that's a little side feature. For us as a utility, you look at the fleet deployments. If you're going to put in a small charging facility for about 20 vehicles, it'll take you 3 months to get the upgrade. If you go to a bigger station, about 20 megawatts for things like Tesla, you're talking 24 months at best, more likely 48 months. So it's a long time. So imagine buying yourself, like the Pepsi guys, they bought a fleet of 15 Tesla semis, and they came to us for power, and it was like, oh, well, that's 4 years from now before you can charge it up. It's a long time to wait, you know? And you see this from Amazon. These guys, they've got about 100+ sites, and they state the hardest part of this is not installing the chargers, but it's going through the process of permitting, approvals, logistics of installing the power and getting the infrastructure. That's the hardest piece. So this is a challenge, yeah? And why wireless gives you this advantage is that if you go to a dedicated place, you have to consume the real estate. So real estate is very expensive. So you have to get the vehicle in and out as fast as possible. So a fast charger, 250 kilowatts, you're probably going to get the 6 charges about a 2 megawatt load. They're going to say, okay, you're going to need to do a service upgrade. So depending on how much power required is how long it's going to show up. Whereas a single controller that's in the car park and you can get it wherever you want, you can get 12 spaces covered here at 20 kilowatts, which is enough. And you can take charge from one bus or one truck and put it into the other truck if you need a rapid charge. You're not going to go in front of the meter. You're going to do this all behind the meter. So you probably only need about 240, 250 kilowatts worth of service or more load. So you won't need an equipment upgrade. So you can go electric very, very quickly. And so can we do this at SMUD? I'm a big proponent of eat your own dog food before you foist it on a bunch of residents. So it's like, hey, how can we do this? So what are the benefits for us? Obviously, we can get charging it much more quickly. We can get our vehicles to participate in grid services like arbitrage, and it's less labor to plug these things in and out. And the end result was we're going to get a lot less yard furniture. And so we have about 900 vehicles in our fleet. About 500 of them are EV convertible. We have about 130 or so that are actually electric now. And so it's about a 13% conversion. And this is the yard furniture we see already. So we have these big orange barriers through these beautiful car parks that are really first-class facility. And we stick in this crazy collusion of wires and cables and stuff. That's not exactly ideal.
You're not making the parking lot worse. It's already a parking lot.
Exactly. But to get your vehicles in and out, we've got a bunch of trailers. They park in different places. They don't show up at the right time. How do you get a trailer in and out? Are you going to get the vehicle off the back? All these issues. And we're going to turn our yard into this giant yard furniture crazy contraption. And each one of these vehicles are probably going to have its own charger because they have different plug. They go at different rates. And it's just a logistical nightmare. So wireless seems like an ideal application for a giant yard like this. And so I did a sketch with what would 500 plugs look like? And it's just a massive forest of these little stalls everywhere. And each one of them and then you compare it to putting the wireless chargers under the asphalt. It'll look exactly the same as you are today. No change in logistics, much easier to deploy. And if we're going to electrify a yard, we're going to create a lot of yard furniture. So the next logical step, I'm thinking, is why don't we put it in the roads? Is it the next logical step? I'm not sure. So it's how and why it can be deployed today. Obviously, it allows electric vehicles to charge during the day so we don't peak the grid. Off-the-shelf solutions are available today, and it reduces the amount of heavy vehicles that are heavy batteries required, and it plays to utility strength. We're a network operator. We're very good at that. And not many other people are good at operating these network of high cost, high value infrastructure that's reliable. And so this is how it kind of works. Put the plates in the ground. We take it directly off the bulk system. So it's not a distribution system. There have been very interesting control boxes that allow you to step down from the high voltage system directly into the road. So you're not creating a system that'll peak the distribution system. We can work cleverly with the battery management system so we can keep the battery at the right charge so you're not stressing the chemistry in it. And there's a lot of funding out there. It's just been changed, like AB 823 is changed now, so we can take the infrastructure bill and we can count towards doing underground infrastructure like power on the road or wireless charging. Electron is one of the companies that's really at the forefront of this. They give the example. It's pretty quick to put the stuff in. They go down about 6 inches. It takes you about a night to do a kilometer, and then you can repave back over again. So it's fairly seamless to put this in the road. It's not going to be too much traffic displacement, and then you can do all the electrical work on the side while the traffic's still going. And this piqued our interest, yeah? So it's like, wow, okay, this is quite interesting. Let's join Aspire, which is the national center in the United States up in Utah for this. We're collecting all the research around how this kind of work will go. So here's a picture of us walking on the road that's electrified. We didn't die. We didn't turn into crazy people. So it's quite safe. It goes into asphalt. It also goes into concrete. So depending on the surface, there's a bus running around that's wirelessly powered, and there's an 18-wheeler that's got all the pickup pads, about 100 kilowatts on this one. It's going to about 1.5 megawatts soon. So we wanted to learn how this was done, and Electron did a fantastic display where they set the world record for the longest non-rechargeable drive. They took a regular RAV4, which only has an 18 kilowatt hour battery pack, and they drove this thing over 1,200 miles. It took them about 100 hours. Had students changing in every 2 hours to drive this thing around. They basically drove this thing around for 4 days without ever stopping to refuel it. And that's only an 18 kilowatt hour battery. So some of the stuff that's going on in Aspire, which is quite interesting, they're demonstrating this megawatt power capability for a Kenworth, an 18-wheeler. And this is a truck that's operated by UPS. They're doing this medium voltage grid tied conversion machines. They're demonstrating this high voltage displays all the way up to 1,000 volts for wireless transfer. And they're looking for input from folks like yourselves. How can you collaborate on this? So it's very much an open book up there. This is an area that you should definitely take a look at because you're interested in the space. This is a fascinating space. Some of the other areas that they're working on, they're pioneered this 230 kilowatt power transfer to put in a highway. So this is with Indiana, and one of the professors there, he showed that you could do 25,000 traffic passes over this vehicle. And Kieran McFrady is one of the leaders on producing or developing the capacitance chain technology. So this one's coming on really nicely. So this is really some interesting space where research and business all come together in this one particular place. And we see this starting to appear in our world. You know, Sweden is one of the leaders. They've got a 13-mile stretch now that's coming online for buses going permanently in place. Tel Aviv has a bunch of bus stops that have wireless chargers going in. Norwegian companies working with the Orlando folks to put something in the highway there just by in Florida. There's something in Germany. There's one in Italy, and now we've got our first thing in Michigan. This was announced earlier last year, and then finally went into place. It's got the attention of even the CEO of Ford here. So this went live, so you can drive your e-transit up and down. A little place in Corktown. It's alive today. And so we have our first real road. The next one that's going actually into a highway, which is different from a regular road, is going in Indiana. And that'll be a 230 kilowatts, so you can drive an 18-wheeler essentially indefinitely and drive at 65 miles an hour, pick up your charge as you're going along. It's a very interesting place. And in California, we finally got one. We were the leaders a long time ago. We've kind of let that go, but we're coming back. So this was, again, an Electrion project working with UCLA. And so we're going to deploy wireless in the southern part. Hopefully we'll get something here in the northern part. There's a bunch of trucks now authorized for wireless. Kenwood lets you put a wireless kit on there. A bunch of cars allow you to do that. BMW is rated for that. Nissan is rated for that. We're testing a Whitricity Mustang down in Sausalito right now. Hevo working closely with Stellantis on their Jeep, the Ram, Electron working with Toyota, and then obviously the Oak Ridge working on VW with the Porsche. And now we are seeing this stuff from Tesla. They're teasing this stuff. Well, they're going to go wireless. I think once they move, I think the rest of the industry will probably follow to offer this as a feature on their cars. And that really opens up the opportunity of vehicle to grid, yeah? We call it V2X, home to load to grid. All three different types, really bi-directional charges. And we have a test site going with Fermata. We have a little Nissan Leaf that's doing this bi-directional charge in our yard. So we're experimenting with this stuff. There's a bill that's just passed. This is the Skinner bill that's now in the CEC's discretion. They can mandate whether a vehicle has to be bi-directional cable if it's going to be sold in California. So we'll see if that comes to pass, how far they'll push this rig. And that's been followed up by the Brownlee bill, which is really trying to do the same thing on a national basis. Can we mandate that all cars are bi-directional? And VDX charging, this is a picture of our little leaf there with our R&D guys running the thing. So we're actually experimenting, dispatching the car with what we call our germ system. So we can actually dispatch the car from our main system. And we're working a lot on school buses because they have massive battery packs in them. And our germ system, we use 20.30, which is the communication protocol. So we can sit in our dispatch room for operations and we can actually dispatch the battery in a school bus, which is quite interesting. And vehicle to X, it really opens up the opportunity for customers to offer or participate in grid services in this two-way grid. And it allows a school bus, for example, to kind of offset the cost of buying these vehicles if they can participate in grid services. And just to give you an idea where we think the market is moving, this is our sort of estimates of how many EVs will be in our territory. By 2030, we think there's somewhere around 300,000 vehicles running around our territory. And that represents potentially somewhere around 17 gigawatt hours worth of storage. Huge amount of storage. We'd like to get access to it. And our utility is quite unique because we're quite small. PG&E calls us the donut because we're stuck in the middle of PG&E territory and we're quite flat. We've got all these truck routes that go between us and our customers seem to love us. They put their number plates on the back of their cars. So we took a picture of this guy driving down the other like a rock car. So we think it's quite interesting. And you can conceptually think about I-80, I-50, even the I-5, they can function as toll roads. Everybody going from the Bay Area to the Midwest, we could charge them up because we're half the price of PG&E. They're going to come to us and we can essentially set up a toll road without it being a toll road. Somebody did an analysis of Highway 5. What would it do? This is a while ago. So this is when the price of gas was $3 and electricity was $12. So this is a while ago. But they've all kind of gone in together. But this study, you'd basically save somewhere around $600 million if you went electricity versus using liquid fuels. I did a quick analysis on one of our on-ramps. It does about 2,500 vehicles every day. If this thing cost about $1.5 million to install, you'd generate that revenue back in about a year. So these things could be quite interesting financially if done just about right. So I think the opportunities out there, I think we're seeing this conversion of sort of accelerating technology coming together, shared mobility, wireless charging, V2G, automation, they're all happening together. So bidirectional charging and V2G is a thing that's starting to occur, and it's really helping with this coming wave of vehicle autonomy. So I think that they go together. Wireless charging probably is a vehicle enabling technology. We're seeing vehicles, for example, this NVIDIA road sweeper in China. It runs around 24/7 sweeping the streets. It's a wireless charger. The Zoox vehicle down in Fremont, that's a wireless charging capable taxi. It has 135 kilowatt hour battery, so a massive battery, but it's a wireless vehicle. Tesla obviously gone all in. Yeah, they're probably betting the company on robotaxis. Just to give you an idea about Waymo, they just did an announcement recently that they were very proud of the vehicle. They went to the charger bay and put a little blue light on. So I did some quick math on it. They do 150,000 paid trips a week. That's about 1 million miles a week. I think if you're paying a prevailing wage of $100 an hour, that math is wrong. I'm sorry. It's about 400,000 a year that they would save in labor costs if they went to a wireless charger as opposed to just having somebody plug this thing in. And you can think about this for on-demand point-to-point transportation, low-cost transportation like the Glideaways vehicle down in San Jose. Wireless is an enabler for that. You could think about 25 cents a mile for public transportation. If you get down to that price, you could flip the whole concept of public transportation where the majority of people go in public transportation rather than the minority. So it opens up, could we obsolete these things? They're point-to-point, they're very expensive, require a huge amount of subsidy from us as taxpayers. This becomes something that's much more convenient. There are these things running around today. City, this project in China, there are about 10 buses, about 10 people on each one of these buses. They're wirelessly charged and they're autonomous. So China's way ahead of us. There's a fantastic place where I've been pitching the Sacramento folks to go and do this. We have this bus lane on Watts Road that's never used. It costs about $1.5 million to put this thing in. And this would be a perfect place that you could create a little off ramp for anybody to use, buses, Uber drivers, anybody go down that and take a charge. And you could think about this as a way to solve the shortfall that we have in our area. There's about $700 million worth of backlog of road maintenance. People are complaining about Watts Road, has these giant potholes in it, and people are complaining they spend a huge amount of gas tax and still have to go over these potholes. Maybe a car on the road as well, then is a way to provide a regular financing mechanism for the road authorities. So in summary, if we adopted a strategy based on power on the road, a utility like SMUD, maybe use this as an innovative way to usher in a whole new way to fuel our transportation. It's a massive revenue opportunity. At the same time, we can avoid our climate change. So I'd like to end this. My son, he's 8 years old. I'm imagining him, this is him in 50 years from now. His daughter is asking him, Dad, did you really have to fuel up your car? And did you have to worry about climate change? That's what I'd like to hear before I die. And what we're talking about, you may think I'm a crazy person, but I just want you to think of the other crazy people as well.
KV line, that's all the control center, so I need you to ramp up 150%.
090500, have you open, check open switch Julia 179, breaking parallel between circuit breaker 11 and circuit breaker 16 at Sand Creek.
That's it.
Right, great question. Peter, one of the biggest sources of, when we think about kind of communities that would benefit, you didn't really kind of talk to this stuff, is port communities where there's lines of diesel trucks just idling, waiting to get loaded up. And it seems like port might be a really good first application. Is that something that you've seen kind of momentum for as a way to try to address, especially local air pollution as well as kind of this transition?
You mentioned momentum, so this company was called Momentum Dynamics, they now call it inductive charging, and they're focusing purely on these ports. So Salt Lake City is one of the transition hubs where they have a potential project going in. The other one is down in LA, where they're trying to work with the port there, because that's one of the low-hanging fruits for this kind of technology. So it's absolutely one or two companies that have specifically focused on that opportunity, because diesel idling is a huge problem.
How's the efficiency of this wireless charging compared to traditional plug-in charging? I know there's like AC and DC plug-in charging, those have different efficiencies, but it seems like you're gonna encounter a ton of issues with the wireless charging, considering that every vehicle on the road is a different distance away from the road. And some of them are quite far away.
Yeah, and this is what all the standards are all about. So the standards that were developed and all the research that's going on in places like Oak Ridge work on exactly this. If you change the gap, you change the size, are the efficiency going to be the same route? And also the power rating. If you put in power via plug, the efficiency drops off dramatically the slower the amount of power you put in. And you don't see that with wireless, which is quite an interesting situation. So that's an area of massive research. The gap, alignment, all this sort of stuff. There are tons and tons of people who work on that. People have done their PhD on that subject alone. So it's a very valid area of research.
Do you have any top of your head figures?
I don't. I'm not a sort of gap analysis alignment expert at all. I know people that are.
But Peter, you referenced, I think, 90%.
That's typically what people are quoting, around about 90%. The ONR study, anywhere between 94 and 96% on the Kia, which is about a 5-inch gap. The Taycan was better, about 96%. So it changes depending on the gap. You're exactly right. It does change it based on the gap, the alignment, all these things change. So you can't sort of like, this is the efficiency. It's very, very much a dynamic situation.
Does it heat the battery?
Does it heat the battery?
Well, like maybe I don't know a ton. Well, I certainly don't know a ton about inductive charging, but I do know a little about inductive stoves. And inductive stoves can boil a pot of water in just a couple of minutes. So it sounds like if you're dumping, I don't know, a couple of megawatts into an inductive coil to charge a car, the car might also get quite hot, reducing the efficiency of that charging.
Yeah, so heat is a big deal for any kind of charger. So if you're charging at a sort of 300 kilowatts, you're probably going to lose about 5% of that as heat. So that's somewhere around 15 kilowatts. I mean, that's a big heater. 15 kilowatt heater is going to generate a bunch of heat. So you see all kinds of strategies to deal with that in cables, like you have liquid cooling in the cables. Same thing for the pads, they have liquid cooling. You modulate the rate of charge in your vehicle. Heat is a massive issue that people did. And again, people have done PhDs on how to solve this problem, how to dissipate the heat. That's a massive area of study. And nobody has a real answer on it right now, but people are working on that tech. So it's a very valid concern.
Yeah, so this March, I also have a very quick business page. It's about the wireless charging. So this is also the competition held by DOE. So they are questioning me with 2 questions. The first is that they want to ask like, what's the real business revenue you can make from the company's perspective? So I'm seeing this question for a long time. So I'm just curious, like, if we are doing the company for the wireless charging, right? So what kind of revenue can I make? For example, we build the equipment or we provide the service. So from the strategic advisor, like which kind of thing do you think should be the best for the business revenue? And also my second question is like, the wireless charging hasn't been adopted rather in the US country, right? So what do you think is the biggest challenge for this kind of technology being adopted? Is this like from the legislation perspective or from the technology or from the cost perspective? And also if it's being adopted, will this cause a large burden from the electricity supply side? Because billions of people will just use this and then will cause a huge burden for the electricity power supply. So
That's a very large question. So I think the first one is really, what's the business model, yeah? And it's, if you're competing against something like the two models, one is home charging. People are used to getting very low cost home charging, it's convenient, versus on the road charging, typically DC fast charging. You're gonna see rates around 50 cents a kilowatt hour for DC fast charging. because a DC fast charger will probably cost you somewhere around $170,000 per charger. So it's very expensive to put one of these in. So to get the investment back, you have to charge a lot of money. So you see a lot of charger companies going out of business. For example, FreeWire is just a recent one that just went out of business. They had a neat model where they had a battery in place in the back of the charger, so they didn't peak the grids. They could charge up separately, and then they could give the fast charger to the vehicle. But even at 50 cents a kilowatt hour, they still went out of business. So it's very challenging to deploy that. It's unclear what the business model is right now for DC fast charging. And then the second question is really around policy, I think it was. How would this impact the distribution system versus the power system? And the real challenge, if we're a residential basis, we have to do rate capture. So we're not allowed to amortize our costs back to our ratepayers. So that's on the distribution system. So the idea here is what these units that can take it from the high voltage system, which is the volt system, we don't have to go to the distribution system. So we don't have to sell the power at 15 cents a kilowatt hour, same as our residents can get out. We can buy bulk rates. We typically buy solar at about 5 cents a kilowatt hour. That's very different than 15 cents a kilowatt hour. So if we sell it at 20 cents a kilowatt hour versus 50 cents a kilowatt hour for DC fast charging, we're going to give the consumer a huge advantage buying from us. And it's almost comparable to the same prices you get out driving from your home. That's the typical rate that you probably get at PG&E at your home rate. So we can be competitive against home charging and the convenience of being able to get it while you're out and about. And the other bit of this is we can actually allow you to participate in grid services. So if you've got extra power in your vehicle, power prices happen to be high at the time, we can say to you, hey, how about give us a few kilowatts back and we'll pay you excess for that power because we're going to stop the grid peaking. So you can participate. I have this idea, I'm calling it currency, like a token, a currency. And we could create a token that you could buy the power and you can sell it back to us. So you go into a Starbucks and you can depend on how the price of power, you can pay with $1 or you can pay with currency. Because you're just going through the drive-in pace and you don't actually have to pay money to it. So it opens up all kinds of opportunities if you're constantly connected to your charger and your vehicle can communicate using software. So those are the two areas. I think we can compete very well against DC fast charging, and I think we won't spike the power grid because we're going to come off the bulk system rather than the distribution system.
Hi, great presentation. Thank you so much. What does the operations and maintenance protocol look for the in-road infrastructure in terms of time, money, ease of access?
Yeah, again, this is another one of the PhD studies. There's so much to be understood on how much they cost to install, is it going to be concrete versus tarmac? What does the weather do for the reliability of this thing? How heavy are the vehicles going over the top of them? How are you going to connect it into it? What's the disruption? There's massive questions, and none of these are known at the moment. This is very, very new technology, so that's why we need these pilots, like the one in Salt Lake City, like the one in Michigan, like the one down at UCLA, to go and experiment, to actually go find out what are the real world costs of maintaining these systems, operating them, installing them. Are there benefits from scale? What's the learning curve going to be like? You know, is it $7 million to put this thing in the road, or is it $1 million to put it in per mile? Where are we going to be on the learning curve once we go through scale? So we don't know the answers for this, but I bet you guys, you could make a fantastic career studying this stuff because nobody knows and everybody would like to find out.
Just building off of that, then how do we solve the chicken and the egg problem that we face with traditional EV charging anyway, with the wireless charging? Because to do pilot studies, you can put in the infrastructure, but then you also need the cars which have that their own infrastructure wirelessly charge to figure out how it works for both the cars and the operation and the infrastructure.
Yeah, it takes lunatics like me to go and move the needle. Yeah, so I have a fellow lunatic who works at Electrion, and we work closely together. So he got this project down at UCLA done. Requires a huge grant to support it, and so you can put the infrastructure in place. And then work on the other side of this was the OEMs, yeah? How can we push the OEMs towards including this? So we have a Ford Mustang being tested down in Sausalito with Whitetricity. And could this be an option? Is this gonna be an option for OEMs to add a new feature to it? And what I suspect is gonna happen is that Tesla are gonna come out and move the market. They're gonna say, they're gonna offer this, and everybody else is gonna have to follow. Because they're like, oh wow, this is a feature that everybody wants, this is a feature that people like, and it's gonna start at really at the high end, where rich people are gonna like, I don't wanna put my car in, I just want it to park. And so that's gonna drive the market, you know, it's like, and then it'll move down the scale as we go through the learning curve. And so I suspect it's gonna be just like everything else. When you buy a giant flat screen TV, they used to cost $10,000, now they're $500 at Costco. And I think it's gonna be the same thing. They'll be available in high-end cars first, and they'll be a luxury item. And that's the way you'll see market adoption. So we start to get around this chicken and egg situation. Once you see adoption, it'll be like the step curve where you go, wow. Once you see the benefit of it, then you'll get this essentially a flywheel effect occurring.
Korean doesn't like to wait for a long time, so it sounds really good idea. But however, if we to install on the road, how can the utility company charge to individual drivers? And are there any safety or maintenance issues?
There's 3 questions, yeah? How to bill it, how to maintain it, and its safety, yeah?
Yes.
Yeah, okay. So how to bill it? There are a lot, very, very easy ways to track where the vehicle is in relation to its charger. Software does it all, and when you're linked up to our germ system, it's very easy to link it to your account. So currency may be a way to do that. Use it as a token. So that's our token for a way to pay it, or we can go through Visa or one of the other payment mechanism. But it's probably going to be on your bill, something like that. So all residents in Sacramento can access these units. So it's very easy to detect which car you are you authorized? The challenge for us is what we call the interconnection. So when you go stick a new battery or solar on your house, you have to go through an interconnection process that allows you to backfeed into the grid. That typically takes 4 hours for us to study each interconnection charge. We charge about $470 for each interconnection. So we're wondering, is every car going to have to go through this process? Are we going to have to do the interconnection agreement for each car? Will they get some kind of license, some passport? We have no idea how that's going to work. Because when you backfeed into the grid, this is an asset that can power the grid, and our techs are out there, they're not expecting it to be live. So how do we guarantee that this thing's going to be safe and not backfeeding into the grid? So that's one safety issue. The other safety issue is like the electromagnetic emissions from this. SAE have very strict controls that you can't emit beyond a certain level that's safe. So that's all built into the standards, and all manufacturers will have to be adhere to that. So it's a very safe technology. It's just like your toothbrush. And billing, safety, there's one other, I'm sorry. Maintenance. Again, this goes back to the question, we have no idea on the maintenance. This is just a massive area. You've got Kim and Afraidi's done 25,000 passes, and it survived. But who knows, we get potholes in the road. There's a whole group in Iowa that studies pavement dynamics. And they do it there because they have the most extreme weather. They have 100 degrees in the summer, minus 50 in the winter, and their pavements just destroy themselves. So that's a real center of excellence up there. And they've joined Aspire to add that expertise in there, because this is an area, how would this interact with the road? And maybe in 20 or 30 years' time, we might abandon this stuff. We might be all in flying cars, and are we going to recycle these things, or are we just going to leave them in the road? What's going to happen to them? So nobody knows this, and this is again an area for research. You may create a career on that.
I think you make a compelling case with regards to like the fleet vehicles, because of their, I guess, the way that they behave. Maybe it makes it difficult for them to charge during the most optimal times of day. But my understanding is that the majority of like personal vehicles are already able to charge, when you get to work I don't have an EV, so I don't know. But like my understanding is that, most people with, a personal EV can drive to work and charge during the day from solar. Is there, like, what share do you think of electric vehicles is in this more like fleet vehicle type group where you are required to charge at a certain time of day?
Yeah, so those are two questions again. So in our fleet situation, we're typically park our fleet about 4 o'clock. So we can run around and charge up during the day, and our peak is 5 to 9. So we had 900 vehicles, dropping that all into our grid between 5 to 9 would be a fantastic asset. So it makes a lot of sense in that case. But as far as personal vehicle goes, in our situation, not every one of our car park spaces are chargeable capable. So we have this little app that we can all go in and we shuttle in between getting access to the charge. We have a lot of EV drivers in our crew, not all of them. But so we have these spots that are not always available. And they typically level 1, they're not level 2. So you can't get access to faster charging. So these are all challenges that we have. And to put in higher charging, we have to upgrade our substation. We may be waiting 4 years. Some of these things are now on 6-year wait lists because substation, it's hard. We're the utility. We have a bunch of these sitting in our yard, but we can't, those are for emergency. We can't just say, oh, we'll take that and put it in our yard so we can have our employees charge. So it's not really capable that you can charge during the day. And our policy is charge it at home, top up at work. So even as a utility, we don't have the ability to charge people card during the day. We'd like to change that. Well, I'd like to change that as a policy. So we dump a bunch of solar in because we buy curtailed solar. Sometimes at we call it negawatt, so at minus prices, and we could just dump it into all employees, and they could go home and dump it into their homes, so we can flatten the peak. And we think that's worth about $60 a month if you participate in grid services using a vehicle. So if you think about buying a car, you got to lease the thing. Maybe it costs you $200-300, something like that. If you're a low-income person, there's so many subsidies available. You can probably buy a new car for about $8,000, a new EV. And if we can contribute $60 a month to it, you might get that car for $50 a month, something like that. So it's an opportunity for low-income people to participate in this EV revolution. High-income people are going to buy these things because they like driving a Tesla. It's a better car, yeah? But low-income people are getting left behind, and they're the people that drive the most amount of miles because they typically live further away from work. And those are the people that would like to benefit from a reliable vehicle that's low emitting, so you don't pollute the neighborhood they live in. And so we would like to give them access to this kind of service. So if we can contribute to reducing the cost because they can participate in grid services, fantastic. And when they get home, we're kind of eliminating gas in our territory. We don't sell gas. PG&E sells gas in our territory, so we're going all electric. So we're kind of forcing everybody down to this one energy source. So we should be doubling down on making it more reliable. So if your vehicle can then, if the power does go out for any reason, you can use your car as a backup. You don't have to buy a dedicated battery, plug your car in, you can power your home. So we can double down on this resiliency issue. Use your car. It'll help you get through an emergency. Doesn't answer the question specifically, but that's how I respond to that.
Yeah, thank you. So for the CO2 mineralization financial mechanism, I understand you're basically taxing EV drivers and moving that money to carbon capture. Wouldn't it make more sense to tax bad behavior, for example, combustion engine, rather than disincentivizing like a good behavior that is like electric vehicle usage?
So that's a complicated question. So carbon taxes, we've tried many times. Yeah, John Kerry is one, he's a big proponent of carbon tax. People don't like taxes. Like, you tax me, I don't want that. That's just an automatic reaction. Yeah. So the subtlety of this program is that you're going to get an advantage going to electric. Maybe a cost reduction 3 to 1. If you go to the wireless, we can give you an extra reduction because it's going to be not 50 cents a kilowatt hour for fast charging. It's going to be 20 cents a kilowatt hour for charging wherever you go. So that the person driving is going to get a mega advantage for going to us. At the same time, we're taking money away from the oil companies because they're not buying oil anymore. So the resident sees a benefit because they're getting lower cost transportation. And you can divert some of that money towards healing the atmosphere. Because right now, we don't pay, we just dump it in the atmosphere and there's no cost to it. There's no way to put a cost on it. People hate taxes, but if you get cheaper power and it's more convenient and it's faster and better, then they're like, yeah, I'm happy with that. Part of the side effect is that it goes towards healing the atmosphere. I'm cool with that too. So that's my concept. Whether people buy into it, I have no idea. We'll only find out. This is what we'll experiment with. But great, it's probably the crux of this thing. Somebody way at the back and then we'll go to you.
Thanks, Peter, for your talk. It was great. I have been thinking a lot about like possible environmental implications of specifically the carbon mineralization, just dumping a bunch of magnesium oxide in the ocean. I mean, I'm thinking for one, like a bunch of extra magnesium in a coastal environment is probably really not good for all of the life there. And I mean, on a global scale, dumping that much magnesium to actually neutralize all of this carbon would screw up all the thermohaline circulation that's kind of powering the climate. Yada yada. Do you have anything on just like all of these implications? It just doesn't seem practical or reasonable to, you know, have some sort of chemical solution, even if it is kind of safe at smaller scales. Yeah,
it's a huge concern for me. It's like when I looked at this, it's like Planetary Tech, I know these guys and they're mining in the Bell Pit, et cetera, yeah. So, but I'm a windsurfer, I'm in the ocean all the time. I'm like, there's no way you can dump this stuff in the ocean. This is probably not a good idea. But there's a NOAA study they gave University, I think Delaware in Chesapeake Bay, where they're trialing this out. So it's an impartial test. Because we do this already in the sewage works. We change the pH going to the sewage works, so you can manage the microbes. So there's a study going on that will happen over the next 3 or 4 years to see actually what happens on this on a microscale. There's a number of other studies, one in Wales and England. Well, I don't know if they call them the UK. There's another one going on in Vancouver. So it's an area, the jury's out on that.
sure.
But it's a lot further down the track than a quarry is. And I'm very much attracted to a quarry because these places are just so screwed up. There's a place called the Berkeley Pit. It's in Wyoming. It's so toxic. They have a sniper that goes out in the summer with rubber bullets. And his job is to scare away the migrating birds when they're on the flight back, because they land on the pit and they drink the water and the acid dissolves them internally. And that's just a horrible way for a bird to die. So this sniper's job is to scare away the migrating birds so they don't land on this pit. So if you can mitigate the acidity in this pit through something like this, you're probably going to improve the environment rather than make it worse. So that's why I'm very attracted to this idea of each utility adopting an abandoned mine that's already completely screwed up, and the EPA is having to spend ungodly amounts of money. The Iron Mountain, for example, is $1 billion. That's a very expensive mine. There are 40,000 mines abandoned in California alone. So this is a massive problem. So if we can find the right spots and we're not going to screw up the atmosphere, they're all contained, then it has a better chance. The challenge for a quarry is they're much earlier in their development cycle. Planetary Tech is much further down the track. They've been around a lot longer. They have a lot more funding. But I'm a big fan of Kate Murphy. She's the founder, and her co-founder is a mining expert. And I'm very much into that, and I'm encouraging them to go hard because of exactly this. I don't want to be in an ocean full of magnesium hydroxide. My stomach's just fine. I don't need milk of magnesium when I'm out windsurfing. I'm fine with that. So yeah, I'm totally with you on that. There's a question.
Yeah, I'm just wondering what the trade-offs are kind of between putting more investment into highway systems when I know there's a lot of kind of equity concerns and actually interest in decommissioning certain highways, especially ones that are kind of run through disadvantaged communities and moving towards more public transportation. And this seems like it would just kind of be a motive to put more investment in highways.
So I'm totally with you on that. So I didn't show you these on the slides because there's a billion ways you can take this thing. It's a giant rabbit hole for people like us that are into this rabbit holes. So one of the opportunities here, if you go to a wireless public transportation system, you can actually shrink these down. So like the glide-away solution, so they become essentially personal vehicles, so 1 or 2 people, become very lightweight and very low cost. So maybe $5,000 for a vehicle like this, something like that. It takes you point to point. You can now think about getting twice as many of them on the road compared to a giant vehicle. And so they take up a lot less road. And because you may have 100,000 of these things running around the territory, you could think about a public system based on that. So the majority of people go via public rather than private transportation like they do today. So you could think of a situation where you get rid of 1 car in your family. So instead of being a 2-car family, you go to 1. And then there'll be a lot less people commuting. And so if you think about our suburbs, you could start converting your garage into being an ADU. So you don't need to keep the extra car in there. So this can be an ADU. Low-income people can now move into these neighborhoods, so they get a low-cost house available for them. On the flip side, the homeowner can offset the cost of homeownership, which is going up and up and up and up, because they get a revenue source from the low-income renter, and you start to work on the housing crisis. And at the same time, you're moving everybody into the city away from these giant freeways. So you're not moving out to El Dorado Hills to commute into work, but you're living in the city. So you can start about taking these freeways and getting rid of them. It's a very interesting idea, and reducing the density of cars by making them smaller rather than bigger, and increasing the utilization. A wireless transfer allows you to do that because the vehicle can run 24/7, and it can be autonomous, and you can have a small battery on, so they're extremely cheap. So the cost per mile is going to smash a private vehicle. It's about 70 cents a mile for a regular vehicle. These things could be as cheap as 25 cents a mile. So you don't need to own a vehicle. So it plays into this idea of getting rid of the freeways. I hate the fact that our city is a classic example. We have 80 and 113 going through it. I floated the idea, why don't we just dig up the freeway, move it 5 miles south and move I-13 west, take the city and turn it into a city. Let's get all the real estate back. We could double the size of our city without expanding our boundary, and sell the real estate and create this like fund that we'd never have to pay property tax ever again. So you get rid of the freeway, it has a lot of advantages. So I love your idea.